My name is Goodness and this is Limpid Scholars Tutorial. I will be handling the 2021 Physics 2021 UI Post-Utme past question. So let's go together with number 1. Which of the following gives the widest separation in the spectrum of white light? A. Green and yellow. B. Red and indigo. C. Red and violet. D. Blue and green. So we'll solve here. These are solving these sheets. So now number 1. White light disperses into different colors. White light disperses into an acronym I called Roy Weave. And this is what? This is red, this is orange, this is yellow, this is green, this is blue, this is indigo, and this is violet. So according to wavelength, red has the longest wavelength and what? Shortest frequency. You get? Red has the longest wavelength and shortest frequency. While violet has the shortest wavelength and longest frequency. So with this, we can answer this question. Widest separation is going to be between red and violet. So therefore, our answer is option C. We're going over to number 2. A sample of monoatomic ideal gas is originally at 20 degrees Celsius. So initial temperature, we'll be taking down all our parameters. Initial temperature is, that's our T1. We have 20 degrees Celsius. Remember, anything concerning gas laws, you take your temperature, your degrees Celsius down to Kelvin by adding what? 273. So using our calculator, using our calculator, 273 plus 20 will surely give us 293. Surely give us 293. I'm sorry for the delay. 293 Kelvin. So now they said, what is the final temperature of the gas if both the pressure and volume are doubled? So final temperature of the gas if both pressure and temperature are doubled means our P1 is P. Let's take our P1 to be P1 and our V1 to be V. Then V1. Then our P. Sorry, I don't know, I'm making a mistake. No one is perfect. So our P2 will be 2P1 and our V2 will be 2V1. Remember they said what? If both the pressure and the volume are doubled. So let's continue. We'll be using the combined gas law, also called general gas law, which states P1 V1 over T1 is equals to P2 V2 over T2. So we are actually looking for the final temperature, which is T2. We're looking for T2. So making T2 subject of formula will give us T1 P2 V2 all over P1 V1 is equals to T2. Then solving it here, what's our T1? 293. Our P2 2P1. Our V2 2V1. our P1, and our V1. So cancelling out P1 and V1, 293 times 2 times 2, we'll be having, using our calculator, 293 times 2 times 2 will give us 1172 Kelvin. And remember, by mere looking at these options, we are seeing that by mere looking here, we are seeing that our answer is in degrees Celsius. So taking it back to degrees Celsius, we do T2 is equal to 1172 minus 273. So using our calculator, 1172 minus 273, 899, giving us 899 degrees Celsius, and that's for number 3. So we'll be going over to, that's for number 2, which is, let me use my cleaner. I think we've answered number 2, so the answer here is 899. We'll be going over to number 3, and this my page is filled. Let me change it. Sorry. Okay, so going over to number 3. A man walks towards a mirror at a speed of 0.25 meters per second. What is the relative motion of the image towards the man? Okay, so now let's just think. If a man moves at 0.25 meters per second, let me highlight this. If a man moves at 0.25 meters per second towards a mirror, his image approaches him at the same speed as the object. You understand? His image will be approaching him at the same speed as the object. Means, therefore, the relative motion of the image towards the man will be actually 2 times 0.25, which is automatically 0.50 meters per second, which is option B. Coming? Yeah. So we'll be going over to number 4. Factors affecting speed of sound in air. This is it right here. So let's read together. Factors affecting speed of sound in air. A, pressure. B, loudness. Temperature. So pressure don't affect the speed of sound. Loudness don't affect the speed of sound. What affects the speed is something like temperature. The higher the temperature, the higher the speed of sound. The higher the humidity, the higher the speed of sound. So therefore, our answer is A. Only. Temperature is the only thing that affects the speed of sound in this context. Here, humidity also affects, but since humidity is not here, let's move over to number 5. To convert temperature from degrees Celsius to the Fahrenheit, the conversion equation is what? Conversion equation number 5 is going to be Fahrenheit. The standard formula is 9/5 times degrees Celsius plus 32. So changing this thing to decimal is 1.8C plus 32, which is automatically option B. Now we're going over to number 6. The velocity of an inclined plane inclined at 30 degrees to the horizontal axis is what? We're doing velocity ratio. So back to our simple machines. Velocity ratio is equal to 1/sin theta. So our velocity ratio is equal to what? 1/sin 30, which is equal to 1/0.5, which is equal to 2. Remember, velocity ratio don't have a unit. It don't have a unit. So go over to number 7. A certain radioactive element has a half-life of 20 years. How long will it take the activity to become 1/4 of its original? I'm sorry that I think this image is a little blurry. This is actually 1/4. This is 4 and this is 1. 1/4 of its original. We'll be doing this is half-life. Wow, into a topic called radioactivity. So remember our formula, remaining fraction. I'll be using formula method, please. I know they can do this thing with just normal reasoning, but I think I prefer using this formula method. Remember, this n here is number of half-life. Let me highlight it. This n is number of half-life. Okay, and remember, total time is equals to what? Total time, let me use my pen. Time is equals to what? Number of half-lives multiplied by the half-life duration. You understand? So now they gave us our remaining fraction as 1/4 in this question. Our remaining fraction as 1/4. So let's substitute it here. 1/4 is equals to 1/2 all bracket n. So if we can reduce this, reducing this 4 to its lowest term will giving me 1/2 raised to power 2 is equals to 1/2 is 2, sorry, let me use my eraser. Is 1/2 because 2 raised to power 2 is 4 n. So cancelling, n is automatically 2. So we're solving for time, not half-life, number of half-lives. Then our total time, remember this formula? This formula is said here, number of half-lives is time is equals to number of half-lives time, half-life duration. Number of half-lives, how many they are, times the main half-life itself. And remember, our number of half-lives is this n. N is number of half-lives, which is n t is equals to n times t half, which is equals to 2 times, and the half-life duration is what, according to the question, is 20 years. See it here, 20 years. I think this is blurry. 20 years. So 2 times 20 years, which is 40 years, and that's the answer. If you have any idea or thoughts about what I'm solving, or you have any question to ask, the comment section is below. Type in your question and I will get back to you. You get it? So we'll be moving on to number 8. Oh, I don't like this pen. Number 8. A uniform wave has a speed of 10 meters per second and a period of 0.5 seconds. The distance between two nearest crests is, remember, distance between two nearest crests is wavelength. You understand? When they say two nearest crests is wavelength they are trying to talk about. So let me change my page as well. Two nearest crest is wavelength. So remember our wavelength formula. This is number 8. V is equals to lambda f. And we're looking for lambda. Making lambda subject of the formula by dividing both sides by frequency, making us V over f. Our velocity here, we have our velocity, but do we have our frequency? No, but they gave us period. Remember, frequency is equal to 1 over period. 1 over period, therefore, I'm coming. So, our frequency will then be 1 over period. What's our period here? 0.5. So therefore, our frequency is what? 2. Because 1 divided by 0.5 is actually 2 hertz. So then, substituting it back into this formula, lambda is equals to V over F. And our V is what? 10 over 2. Therefore, our lambda is 5 meters. So the answer here is D. Our answer here is D, 5 meters. So we're going over to question 9. Question 9. If the cross-sectional area of a resistor of resistance R ohms is halved and its length is doubled, its resistance becomes... Okay, so let's reason this question. Remember, in cross-sectional area, resistance, remember that formula R equals to P L over A. Remember, R is directly proportional to length and inversely proportional to the cross-sectional area. Okay, so now this P here is actually a constant. This resistivity is a constant. So they said if the cross-sectional area of a resistor of R ohms is halved, if the cross-sectional area is halved and its length is doubled, so let's take it like this: R is equals to P. The length, remember the length is what? See, the length here is what? Doubled. So let's double our L, brackets 2L, all over. And its cross-sectional area is what? Halved. So dividing our A over 2. So let's continue solving. R is then equals to P 2L over A times 2. Remember, this is also the same thing. So R is equals to 4PL over A. Then automatically 4R is equals to PL over A. So therefore, our resistance becomes 4R. Our resistance is equals to 4R, which is automatically option A. Yes, I hope this is clear. Any confusion, please the comment section. Going over to number 10. Which of the following is true concerning the magnitude of the electric field at the point in space? A. It measures the total charge of the object. B. It measures the electric force per unit charge on a test charge. C. It is a measure of the ratio of the charge on an object to its mass. No. A, B, C, they are wrong. D. It is a measure of the electric force per unit charge on a test charge. Correct. D is the correct option. Which of the following, let's take this question. Which of the following is true? What's true concerning what the magnitude, the size of an electric field at a point in space? It is a measure of the electric force per unit charge on a test charge. This is self-explanatory. We've come to the end of today's class, today's lesson, physics. You see, we started from here, did here, move on to here, and now we are here. And I think with all this we are done. I want to know your thoughts, and share with your friends, promote this channel. We got the best for you. Much love. Thank you so much.